Now that we've discussed how to solve homogeneous systems with constant coefficients, let's actually do an example. Here's the system that I want to solve. X prime equal to 2, negative 3, 1, negative 2x. Our first step is to write the system in normal form, but that's already done here. So now we're on to the second step. The second step looks at the determinant of a minus ri equal to 0. Well, a minus ri, if I consider that, we know what our matrix A is. And R times the identity has 1s on the main diagonal and 0s everywhere else. So Ri is going to have R's on the main diagonal and 0s everywhere else. And since we want the determinant of this, we have the determinant of 2 minus R, negative 3, 1, negative 2 minus R. To take the determinant, we multiply this way. So I have 2 minus r times negative 2 minus r minus negative 3. And we want to know when this is equal to 0. If I multiply this left-hand side out, I get negative 4 plus r squared plus 3 equal to 0. Or r squared minus 1 is equal to 0. So we have r is equal to plus or minus 1. So there's our second step, was to get r. Our third step is to solve for u. And in this case, we're actually going to have two different cases of our third step, when r is equal to 1 and when r is equal to negative 1. Let's start with the 1 case. For this, I'm looking at solving a minus riu equal to 0. We already said what a minus ri was. That was 2 minus r, negative 3, 1, minus 2 minus r. Times u, which I'm going to denote as this u1, u2. And this should be equal to my 0 vector, 0, 0. So that's what this says. Now, if r is equal to 1, 2 minus 1 is 1, minus 3, 1, and negative 2 minus 1 is negative 3. And then we still multiply by u1, u2, and that should be equal to the 0 vector. This essentially gives us two equations. If I try to multiply out this left-hand side, I get 1 times u1 minus 3 times u2. That should be equal to 0. And if I solve the second equation, I get the same thing if I multiply out that second row. So this is just the same equation repeated. So what I'm going to do is I'm going to solve for u1. I get u1 is equal to 3u2. And then I'm going to pick a non-zero u2. It doesn't matter what you pick, you'll get the same answer in the end anyway. But we want to pick something that is not 0. I'm going to pick 1. If u2 is 1, then u1 would be 3 times 1. So my vector u here would be 1, 3. I'm now halfway done with the third step. I need to repeat this again for r equal to negative 1. So if I scroll down, this time I'm going to have r equal to minus 1. And just as a reminder, we're looking at a minus ri times u equal to 0. This means we have 2 minus r, negative 3, 1, minus 2 minus r. times u, which we're going to denote as u1, u2, equal to 0, 0. Sticking in -1, 2 minus -1 is 3, minus 3. 1 and -2 minus -1 is -1. And then we still have times u1, u2 equal to 0, 0. When I try to multiply out this left-hand side, the first row becomes 3u1, and then minus 3u2. We know that needs to be equal to 0. The second row, 1u1 minus 1u2, should be equal to 0. And once again, I have an infinite number of solutions, and that should always be the case. So I'm going to pick a u2, once again, non-zero. I'm going to pick it to be 1. So then u1 would also be 1. So this time my vector u is 1, 1. A quick summary. We had that if r is equal to 1, then u is equal to 3, 1. And if r is equal to -1, then u is equal to 1, 1. So this tells me that my solution looks like c1 e to the rt, so e to the 1t, times its corresponding u vector, 3, 1, plus c2 e to the rt, so now e to the -1t, times its corresponding vector u, 1, 1. We could write this individually. x1 would be 3c1 e to the t plus c2 e to the -t. Y would come from the second row, c1 e to the t plus c2 e to the -t. So now I have a solution. And we can go a little bit further. So let's suppose we also have that x of 0 is the vector 2, 1. So what this tells me is if t is equal to 0, then x is 2 and y is 1. So let's see if we can use this. We know x is going to be 2. I would have 3c1 times 1 plus c2 times 1. Y is 1. This is c1 times 1 plus c2 times 1 once I let t be equal to 0. Well, I'm going to subtract the second equation from the first. So -1 equals -c1 minus c2. Subtract these. This gives me 1 is equal to 2c1. So c1 is equal to 1/2. I can then use this equation. I know if c1 is equal to 1/2, then c2 is also equal to 1/2. So now that I have that, I can actually write a general solution. I would have 1/2 e to the t times the first vector, 3, 1, plus 1/2 e to the -t times the second vector, which was 1, 1. So now with all of that, I have the actual solution to the initial value problem.